Okay, everything we've seen up until this point had positive exponents because interest was working with the amount of money we were depositing, so it was kind of snowballing downhill. We'll talk about the annuity due formula later. This formula is just the same as the annuity formula with one extra pay period because you pay at the beginning of the period, so everything gets one extra period of interest. What we're going to talk about first is the amortization payments. So the present value of an ordinary annuity or the amortization payment equations are these two, and you'll notice they have negative exponents. The primary reason for that is, for example, in an annuity, you're putting in a little money and you're adding more to that money as it gets interest, so it's just accumulating more and more. And the present value of an ordinary annuity or amortization payments, a lump sum is borrowed, which you're making payments on, but that interest is still accumulating on how much you owe. So your payments are actually reducing the amount you owe, but the interest is still going up. So you and the interest are working against each other. And that creates a different kind of situation. In the case here, A is actually our present value. It's payment times 1 minus 1 plus r over n to the negative nt over r over n. So this is the present value of a structured settlement. So this is going to be the kind of formula you use when you win the lottery, and instead of taking your payments over the 20 years that they offer it, you decide to take the lump sum. They use that to see what the present value of your lottery would be, because $20,000 per month now is worth more than $20,000 per month in 19 years because of inflation. And here, this is the amortization payment. It's to determine how much you have to pay a month when you make a loan at a certain rate. And almost always n, in this case, is going to be monthly, so 12, because traditionally on every mortgage payment, car payment, any of that stuff, you make payments every month. So let's look at how this actually works. Okay, Julian will make payments of $500 at the beginning of each quarter for 7 years into a money market account at her favorite bank, which as of this year is offering a rate of 3.25%. If interest is compounded quarterly, find the future value of this annuity due. Okay, so this is an annuity question, and she's making the differences at the beginning of the period. So the only difference, again, talking about the beginning of a period and the end of the period, if you do the deposit of the money here at the end of the period, it doesn't start gaining interest till the second period happens. But if you deposit it here, then it gets an extra month of interest. So that annuity due equation, the only difference is you have an extra pay period, extra interest period. So normally, our formula for an annuity is A equals payment times 1 plus r over n to the nt minus 1 over r over n. The only difference is you have an extra interest for all costs. So this whole thing is multiplied by a 1 plus r over n, which we just put it at the beginning. So if you get one of these problems, you can just calculate the annuity normally and then just multiply your answer by 1 plus r over n. So in this case, she's making $500 payment, 500 times 1 plus, our rate is 0.0325 over 4, it's quarterly. She's doing this for 7 years, so the 4 times 7 minus 1 divided by 0.0325 over 4, and this whole thing is multiplied by 1 plus 0.0325 over 4. So you can put this 1 plus 0.0325 over 4 at the front. This is what I usually would do when I put the equation on. But this is generally how I think of it. It's a normal annuity plus 1 extra pay period of interest. So it doesn't actually make a huge difference, but of course you know that the homework will punish you for being slightly off. So 500, 1 plus 0.0325 over 4, 2 to 24 minus 1. Let's see, divided by 0.0325 over 4. So she does this for 7 years. She ends up with $15,776.62. Now, of course, we can always check how much is interest and how much she paid in. She paid in $500 4 times a year for 7 years. She paid in $14,000. She ended up with $15,776. Again, that doesn't seem like a huge increase, but when the T that you're doing this over is short, it doesn't accumulate that much. Now, Taylor was in an automobile accident. She sued the person at fault and was awarded a structured settlement in which an insurance company will pay her $2,000 a month at the end of the month for the next 7 years. How much money should the insurance company invest at 4.7% compounded monthly to cover Taylor's lawsuit? Okay, so let's think about this one. They need to invest money now that's going to pay $2,000 a month for the next 7 years. This should be a present value of a structured settlement. So this is almost exactly the opposite, right? Of you borrowing money to make mortgage payments eventually that cancel out the cost. So this should be the present value of an ordinary annuity, or the amortization style equation. So here we know the payments are $2,000. Now we know the rate is 4.7%. We know T is 7 years. So how much should they invest now to cancel out those costs? It should be A is 2,000 times 1 minus 1 plus 0.047 over 12 to the negative 12 times 7, close parentheses, divided by 0.047 over 12, close parentheses, close parentheses. So let's see what this ends up being. We deposit $2,000 at a rate so 47 over 12 to the negative 84th power over 0.047 over 12. So if they deposit $142,924.79 now, it'll pay for all of her payments. Well, how much are they ending up having to pay her? $2,000 a month times 12 times 7 is 2,000 times 84, which is $168,000. So if they deposit a little $142,000 or $143,000 now, it'll cover the $168,000 they have to pay over the next certain amount of time, 7 years. So that's the idea, and we'll do more in the next video.